स्लाइड चाहिए आपका प्रेजेंटेशन मैम वेट वन सेकंड just let me shift the screen.
कौन कौन है यहाँ पर? Good afternoon, everyone. I just want to confirm with the participants of the oral presentations. Please say yes if you're here. Dr. Beena Negi. Dr. Beena Negi.
She's here.
Okay. Dr. Meenu Teshia.
Dr. Meenu, is she here?
Dr. Ranvijay Ram. Dr. Ranvijay Ram. Okay. Mr. Sanjay Kumar. Shobna Acharya.
Shobna is here. Yes, there she is.
Vishakha Chaudhary. Jasmine Kaur. She's there. Anisha. Harsha Haridas.
Harsha is here.
Khyati Chaudhary. Khyati to hai. I saw her. Khyati was here. Hey, Khyati is there. Dr. Rakhi Tyagi. Astha Tomar. Astha Tomar. Mansi Vats. Mansi Vats. In case any of these participants are not there, we'll ask the next speaker to give the talk. Okay, so please be ready with that, right? Thank you. Hello.
ऐसा बदल गया कि पहचान में नहीं आ रहा मैं घूम ही नहीं पाया और
May I have your attention, please? Do we have Dr. Meenu Tertia here? Dr. Meenu? Dr. Meenu, okay. Mr. Sanjay Kumar? Mr. Sanjay Kumar? Anisha? Anisha? Astha Tomar? And Mansi Vats? No, thank you. Good afternoon, everyone. On behalf of organizers, I, Dr. Anju Chibber, welcome you all to the session 3 of this 3 days international conference on integrative chemical science for health and environment 2023. To chair this session, we are privileged to have Professor Rajiv Singh and Professor Manisha Sengher as distinguished personalities with us. Heartiest welcome to both of them, who have significantly contributed to their respective fields and continue to inspire countless individuals worldwide. Professor Rajiv Singh is currently professor in Department of Chemistry, ARSD College, Delhi University. His research areas are material chemistry, hybrid materials, organometallic complexes, and bioorganic chemistry. He is currently running 3 major research projects, including 1 international project in collaboration with reputed organizations. He has supervised a good number of PhD students of Delhi University and other universities. We are grateful to you, sir, for taking out your precious time from your hectic schedule. The other chairperson, Professor Manisha Sengher. She is a passionate teacher and a committed researcher working in Department of Zoology, Deshbandhu College, University of Delhi. She has a teaching experience for more than 26 years. Her forte is human physiology, endocrinology, chronobiology, and stem cell research. She has published a good number of research papers in journals of national and international repute, with an impact factor ranging between 2 to 6.9, and has also presented her research in many national and international conferences. Professor Manisha is also the principal investigator of various research projects funded by DRDO, DBT, and LSRB. She was also appointed by National Testing Agency, Ministry of Education, Government of India, as a content creator for conducting various NEET, UG and PG entrance exams. Over the years, she has constantly worked on health, education, and environmental issues and has contributed in students' training and outreach programs. So now I once again welcome on behalf of we all to this particular session. So I hand over this mic to the chairpersons to start with the session. Thank you so much.
Thank you, Dr. Anju. Namaskar to everyone. I am Professor Rajiv Singh. And along with me, we have Professor Manisha Sengher from Delhi University. And I hope to have some good talks over here from you all. As I've been informed that you have been given 10 minutes. So that means 8 plus 2 is sufficient enough. 8 minutes for presentation, 2 minutes for interaction and questions. So not wasting any much time, I will now request our very first presenter, Beena Negi, to please come over. Beena ji.
Thank you, sir. I hope I'm audible. Good afternoon, everyone. I'm Dr. Beena Negi from Department of Chemistry, Gargi College. Today, I'm going to talk on the topic cyclohexane diamine and isoniazid derivatives as promising anti-tuberculosis agents. According to WHO, there are 6 infectious diseases which account for more than half of premature deaths. One of those diseases is tuberculosis. This tuberculosis is caused by Mycobacterium tuberculosis. It is a bacterial infection and it spreads through air. Tuberculosis affects lungs and it can also affect other parts of the body. The various symptoms of tuberculosis are chronic cough with blood-tinged sputum, chest pain, fever, night sweats, and weight loss. After COVID-19, this is the 2nd leading cause of infectious disease, and it is a 13th leading cause of death worldwide. It is a global pandemic, and every 20 seconds it kills 1 person. In 2021, 1.6 million people died from TB, and around 10.6 million people fell ill with TB. Because of COVID-19, there are increase in the number of TB cases, and approximately 2 million $2 billion are required per year for tuberculosis research. Here you can see the worldwide spread of tuberculosis, and India alone accounts for 1/5 of the total tuberculosis cases in the world. The major other concern from tuberculosis is the resistance. The Mycobacterium tuberculosis has developed resistance to various strains, to various drugs which are currently available, and there are increasing cases of multi-drug resistant tuberculosis, extensive drug resistant tuberculosis, and latent form of TB are also seen. In India, also totally drug resistant cases of tuberculosis have appeared. These are some of the drugs which are used for the treatment of tuberculosis. We all know the DOTS program. The first line TB drugs, rifampicin, isoniazid, pyrazinamide, and ethambutol. These are used for the treatment of tuberculosis. So these are easy to use. And if the person is resistant to these first line drugs, then the second line drugs are used for the treatment of tuberculosis. In September 22, there were 26 drugs which were in different phases of clinical trials. These are some of the drugs which are under phase clinical trials. Out of these drugs, this delaminate and this bedaquiline are now currently available to treat drug-resistant tuberculosis. And these drugs were under clinical trial from past very few years. So this is the scenario of the clinical trial of these tuberculosis drugs. You can see delaminate has reached its phase 4 clinical trial, and bedaquiline is in phase 3 clinical trial. One of the drug SQ-109 is in phase 2 clinical trial. My research work is on cyclohexane diamine moieties, and this cyclohexane ring is present in many of the biologically active compounds like Tamiflu, eloxatin, lorabid, bromhexine, and ambroxol. This bromhexine and ambroxol, they are mucolytic agent, and you must have seen bromhexine in many of the cough remedies, cough syrups. This bromhexine is present. So we have designed this dimer, partial dimer of bromhexine, where you have a cyclohexane backbone, and these are two drugs. One is ethambutol, which is the first line anti-tuberculous drug, and another is SQ-109, which is in phase 2 clinical trial. So both these molecules, they contain this diamine linkage, and our design molecule, the central one, also contain this diamine linkage as well as the cyclohexane backbone. So based on these molecules, we have designed this compound. And initially, we synthesized symmetrical cyclohexane diamine derivatives. So we took cyclohexane diamine and treated with different benzaldehydes, and those shift bases when then reduced, and we got these diamine derivatives. These compounds were tested for their antibacterial activity, anti-fungal activity, and they were also found to be very good anti-tuberculosis agent. These compounds showed no hemolysis up to a very high concentration. Then, based on the promising activity of these compounds on different bacterial strain and mycobacteria, we designed this unsymmetrical molecules so that we can have a better structure activity relationship. For that, again, we have taken this cyclohexane diamine and then treated with first one of the NH2 group is protected and then treated with one benzaldehyde. Then after deprotecting the NH2, we treated with another benzaldehyde, and we could get a series of compounds, and these compounds were tested for their activity against various bacterial strains, and very good activity was observed. Then we tested them against tuberculosis, also Mycobacterium tuberculosis, and ethambutol, the reference drug, has 1.56 micromolar activity, and our compounds were also equally potent. We have this work was published in this paper. Then we have synthesized SQ-109 analog, where we have taken replaced one of the benzyl group with the bentyl group, and we could synthesize a series of compounds similar to SQ-109, and these compounds also showed very good antibacterial and anti-TB activity. Then we have synthesized a lot of compounds so that we can have a very good structure activity relationship. And from structure activity relationship, we could infer that this admentyl ring is well tolerated during activity. This cyclohexane backbone is essential for activity, and alkyl chains at para position of the benzene ring, they show good activity. Then further, we worked on isoniazid, which is used as a first-line anti-tubercular drug. This we synthesized various derivatives of this compound. We linked this compound with triazole moiety, and then these compounds were also tested for their activity against Mycobacterium tuberculosis. And here isoniazid, the drug which is used for tuberculosis, has 0.39 micromolar activity. One of our compounds shows activity equal to isoniazid. And then we tested these compounds on mice infected with Mycobacterium tuberculosis. The first image is of lungs which are infected with tuberculosis bacteria, and image E shows the lungs of the mouse which are treated by our compound. Then we also synthesized isoniazid derivatives with amino ether linkages. These compounds also showed, some of the compounds showed very good activity equivalent to isoniazid. They were also tested against mice infected lungs. So I conclude, we have synthesized ethambutol and isoniazid analogs, and these compounds are very good antibacterial and antimycobacterial drugs. So these compounds can be a promising lead for future for treatment of these diseases. I would like to acknowledge my supervisor, Professor D.S. Rawat, under which I have done this research work, and our principal for giving me this opportunity and permission to attend this conference, our collaborators for doing all the biological activity. Thank you.
Thank you, Beena ji. Now I invite questions from the participants. Anyone? Congratulations, Beena. I have one very small query. You worked using nitrogen. Do you try for working using like sulfur atoms, sulfur compounds?
No, so we just concentrated on a series of cyclohexane diamines, so whether could have a structure activity relationship with that only. We have not used dithiols.
Is there any scope like during a literature survey, did you find that what is the efficiency of sulfur containing compounds
I
in
have not
comparison?
checked it yet.
No, fine, it's a good work. Thank you so much.
Thank you, sir.
So the next presenter is Dr. Meenu Teotia. Ma'am, please. Aye.
Namaskar. Myself, Dr. Meenu Tevatia, and I am working as assistant professor in Department of Chemistry, Chaudhary Charan Singh University, Meerut. Today, I am going to discuss my research work on the topic NN dihydroethyl 1,4-benzene dicarboxamide, a derivative of PET waste that has been used as curing accelerator in epoxy diamine systems. So epoxy resins, these are commercially viable and very important industrial materials because of their key properties like outstanding mechanical performance, low shrinkage, electrical insulation, heat resistance, solvent resistance, chemical resistance. That's why these are very demanding compounds. They have a wide range of applications in coatings as adhesives for structural applications and also in laminating articles, matrices for fiber reinforced composites, in aerospace industry for lightweight composites, in electronic materials because of electrical insulation property, in biomedical systems, paints and floorings. So epoxy ring, we all know it's a 3-membered ring containing one oxygen atom. So during its polymerization, there's a ring opening of this ring, and diamines like ethylene diamine here we are using as curing agent. So that opens the ring and a long chain polymer is obtained. Because this small ring is very reactive towards electrophilic and nucleophilic species. That's why it undergo ring opening reaction. So there are two types of curing agents. One are used as catalyst, which initiate only polymerization, and one act as hardeners. So hardeners are involved in the polymer network. That's why they are important and they enhance or the properties of the final cured polymer depends on the type of agent hardener which we are using. Our work basically on polyethylene terephthalate waste. We all know that it's widely used as packaging material, especially for beverages. And because of large consumption, a lot of PET waste is generated. So all over the world, researchers are finding new solutions for polyethylene terephthalate waste recycling. We have used chemical recycling methods and obtained a number of value-added products like aromatic amides and their derivatives. So here in this work, we have used this aromatic amide derivative, which at the end, it has primary alcoholic groups and amide linkages. Amide linkages, when involved in cured polymer network, they impart impact properties to the polymer. So this is the work: synthesis and characterization of this monomer, then preparation of compositions, then ethylene diamine, which we are using as curing agent, its concentration optimization, then DSC dynamic characterizations, isothermal kinetic studies, casting of sheets and mechanical properties, and finally the glass transition temperature. So we have synthesized this compound, this monomer, at ambient conditions of temperature and pressure with ethanolamine. After depolymerization, we get this. We have characterized this through FTIR, UV visible NMR, proton NMR, 13C NMR, MS, TGA, DT, and DSC. So this is the data tabulated here, and we can see all the peaks are at right positions for all the protons. In 13C NMR2, so this monomer is well characterized through, and this is MS spectrum. Molecular weight is 252. FTI spectrum, then TGA, DTA for melting point. For the preparation of formulations, we have selected epoxy resin LY556, and we have investigated the effect of this monomer on curing characteristics, kinetic parameters, and mechanical properties. Ethylene diamine has been used as curing agent. So we have checked the percentage of ethylene diamine to get the finally cured film. So for this, we have recorded these thermograms by varying the concentration of ethylene diamine from 2% to 3% and 4%, 5%. So these DSC thermograms were obtained, and then we checked that DSC pen after curing, whether it is fully cured or not. So at 5% of EDA, it was fully cured, and then we choose this formulation, and in this formulation, we added further our monomer, HEBD, from 1, then 2%, then 3%, 4%, and 5%. Then we have carried out DSC dynamic characterizations for these formulations using MATLAB Toledo DSC 823 as kinetic software. So 6 thermograms were recorded for from B0 to B5 comprising HEBD. Here, these are overlaid. All the thermograms are overlaid here. We can see in these overlaid thermograms that at 0% HEBD, in the table, it is mentioned heat flow. This is milliwatt 1. Then at 1% HEBD, 1.94. It is gradually increasing as we are increasing the concentration of this monomer. And however, the peak temperature, this is also shifting to a lower value from 1112 to 108. Enthalpy of polymerization at different temperatures is plotted here. This is again showing the same trend that enthalpy of polymerization is increasing while we are increasing the concentration of this monomer. So on the basis of dynamic curves thermograms, we have selected 3 temperatures for isothermal kinetic studies, 105, 10, 115, these 3 temperatures. At these 3 temperatures, 3 thermograms were recorded for each formulation. And these are overlaid here for calculation of activation energy, rate constant, and order of reaction. B4, B5. So this is the data tabulated here. We can see at energy of activation in kilojoule per mole, it is for V0 42.95, then 36 minus 27. It is decreasing up to B5 formulation. We get order of the reaction. So these data strongly suggest that our monomer is participating in the reaction. It is not just acting as a filler there, and it is enhancing the mechanical properties when we test it for mechanical properties further. These are the sheets after tensile testing. We have determined mechanical properties also, tensile strength, percentage elongation, and hardness. For this, we have casted sheets in acrylic molds. This is mechanical properties data. So in the important tensile strength is important as it is increasing from 6 Newton per mm square to 12.07. And there's a decrease in percentage elongation. So we are not compromising that so much on the percentage elongation, but tensile strength is increasing. It has just become double from B0 to B5. Hardness is also increasing. We have also determined glass transition temperature of these films, glass transition temperature for all the films, and these values are also compared here. For B0, it is 48.6. There is a slight increase in glass transition temperature. So these data strongly supports that our monomer that is having amide linkages and primary alcoholic group that is participating in the polymerization reaction. So this is the conclusion on the basis of all these tests which we have conducted, isothermal studies and dynamic DSC characterization mechanical properties. We are here just saying that our monomer is acting as a curing accelerator as well. Curing accelerator. Yes, some of related publications. I thank our Vice Chancellor, Professor Sangeeta Shukla ji, for financial assistance under University Research Grant Scheme. I sincerely thank my mentor, Professor R.K. Soni, Head Department of Chemistry, Chaudhary Charan Singh University, and my PhD students, Ms. Neha, Shifa, Neeraj, for their help in conduction of this research work. Thank you. Thank you very much.
Thank you, Meenu ji. Questions from the audience? Anyone? The work seems to be environment friendly, isn't it? तो questions तो बनते हैं. कुछ तो जानना चाहेंगे हम लोग कि नहीं. You are all students, I believe, and faculty members. In fact, मेरा तो simple ये question, it looks very interesting. So आपने इसको public domain में कुछ utilization के लिए इसका कोई practical कोई testing या कहीं use करके देखा? Because it's a very environment friendly, भाई जो plastic produce हो ही रहा है. Okay. Okay. Okay, fine. Cost effective as well as public domain में आएगा तो I believe it will be very fruitful. Right. Thank you, Meenu ji. Thank you so much. All right. So next we have Ranvijay Ramji. He's a faculty member. Is he here?
PPT. Hello. Yes. Yes. Hello. Good afternoon to all of you. I am Dr. Ranvijay Ram. I am teaching in Maharaj Agrasen College, assistant professor in Department of Chemistry. I carried out this work in IIT Kharagpur. This is the polyvinylidene fluoride based conducting composites for electromagnetic interference shielding application. Now, as we know that we are living in an age of electronics, we everyone have the electronic equipments like laptop, mobile phones, but whenever we are calling, we get separately signals, we talk in a separate way. The electromagnetic radiations are not interfering to each other because in a modern age we are using the modern technology. And here what I have done, I have made one composite which is composed of a PVDF, that is a piezoelectric material, and different kinds of carbon blacks which is acting as a conducting material. So I am going to detail here what are the causes of electromagnetic interference. These are the things like some lightning during the rainy season. You can get it also from the DC and AC voltages. We are using these currents in our house as well as in different departments, scientific or in colleges. These are actually producing some electromagnetic radiation and which are interfering to the other equipments. Okay. And okay, so what is the mechanism of shielding these interfering electromagnetic radiations? Just there are three ways we can prevent to interfere these electromagnetic radiations. One is absorption of the electromagnetic radiation, another is reflection, and third one is repeated, or you can say multiple reflection of the electromagnetic radiations. This only can be done with the help of the conducting material, which has at least 2 Siemens per centimeter of its conductivity. And we get it with the help of a carbon black, which is generally used in tire tubes. Okay. So we are going to make flexible equipments like your mobile phones, because we are always afraid of dropping of the mobile phones, whether it will be cracked. But in coming years, you will get the mobile phone or laptop, which will be flexible enough not to crack anywhere if you throw it in a wall, if you throw it at a surface of the roof. So here I am dealing with the electromagnetic shielding. Now I am going to talk much more regarding that flexible electronics material. Okay. So here I did it electrical conductivity, which is very much required for shielding of electromagnetic radiation, which is going to harm our equipments or proper functioning of the equipment. These are some electromagnetic tested done here. Field emission, TEM and AFM is also done for its morphological study. It is a PVDF, its characteristics, it is a piezoelectric material as well as a pyroelectric material. So I am not going to discuss much more about the PVDF. Conducting filler, I have used 3 fillers like N472, N550 and N774. These are these numbers are depending on the size, structure of these particles. Here electrical conductivity, you can show you can see easily that PVDF N472 material is showing higher conductivity in comparison to N550 or even in comparison to N774. Similarly, here I plotted the AC conductivity. It is also showing the same trends. And here I have taken 5 weight%, 10 weight%, and 15 up to 50 weight% of a N472. Why I have taken N472? Because it is showing the better result in comparison to the N550 or N774 carbon blacks. So here EMI shielding, you can see easily the PVDF is showing the 0 EMI shielding 0 dB, whereas 10 weight% is showing around 10 dB, and your 20% PVDF N472 is showing 30 dB, and it is the EMI shielding which is required to prevent approximately 99.999% of attenuation, which is just caused by the other equipments. So this is the desirable one. And here I have also seen the 50% N472 effects in PVDF. In second figure, what I observed is you can see the 472 is having the higher EMI shielding in comparison to other fillers at 10 gigahertz frequency. And EMI shielding of N472 at 10 gigahertz also shown in the terms of absorption, reflection, and total EMI shielding. Total EMI shielding is even higher than 40 dB. Okay, so these are the EMI shielding effect. I have shown the effect of electrical conductivity with that of the EMI shielding, because you can see as the electrical conductivity increasing, the EMI shielding also increasing. So the EMI shielding is directly proportional to your electrical conductivity of the material. This is also the EMI shielding effect on thickness. As you increase the thickness of the material, EMI shielding is going to be higher and higher. Why I have taken the PVDF? PVDF is a piezoelectric material, and even you can press it, it generates some electricity, and that's why it has a many application. Here, these are the micrographs like FESM of different 10% of N472 and 550 like that. And this is a AFM diagram, or you can say the topography of the materials which I have prepared. This is a concluding remarks, like N472 is having the better EMI shielding in comparison to other fillers. Now, I would like to thank UGC as well as IIT Kharagpur for giving me the opportunity to conduct this research work. These are the references, and thank you.
Thank you, Ranvijay ji.
Yes.
कोई कुछ पूछना
Any
चाहे?
question?
कोई नहीं पूछेगा तो पता कैसे चलेगा? सर ने इतना इंटरेस्टिंग पॉइंट कहा है that हम लोग फोन तोड़ते रहते हैं, and he is going to bring in a phone which is unbreakable,
Flexible enough,
flexible
so you
enough.
can throw anywhere.
आप तो
It will not
Samsung
be
बंद
broken.
करवा दोगे.
Your screen will be flexible, and it will be made up of a semiconductor and semi-transparent material.
So did you make any composite film out of it? Like,
Here
is
I
there any
thought,
material, if you have any picture of it, like, because
sir, I have published a paper.
publish a paper, I mean, this nano composite, have you
Yeah.
incorporated into any material so that the
In
things
PVD.
come out?
Yes, sir. Actually, in semi-permeable or semi-transparent material, we have made with the PVDF and CNT.
Transparent material of what? And
PVDF and CNT.
Hmm.
And I am showing here the carbon black. Carbon black is not too much semi-transparent.
did you make that polymer film?
Yes.
You made that polymer.
Yes, yes, sir.
Then you should have exhibited. No, you could have also seen
Yes,
something. You know.
I have not taken that picture.
Right. So the what you call the conductivity or the electrical conductivity
Is
remains
sufficient for the EMI shielding.
Remains sufficient
Yes,
enough.
yes.
Okay. All right. Thank you, Ranvijay ji.
Okay, sir. Yeah.
Next we have Sanjay Kumar. Sanjay ji. He's from Deshman?
Sanjay, Mr. Sanjay, is he here to present his paper? No, sir, he is not here.
Oh, fine. And then I think we have some students, PhD research scholars. Shobhana Acharya. She will be presenting her work on hybrid nanocapsules. Okay, fine.
Good afternoon, everyone. I'm Shobhana Acharya, working under the supervision of Dr. Monica Singh. I'm from Institute of Nanoscience and Technology, Mohali. Today, I'm going to present on polyoxometalate-based nanocapsule as an anti-neoplastic agent. These are the outline of my presentation. First of all, what are polyoxometalates or POMs? These are actually the metal oxygen anion nanoclusters, which consist of oxygen atoms in abundance and includes the metal molybdenum, tungsten, vanadium, niobium, and thallium in their highest oxidation states. These are the building blocks for the bottom-up assembly of organic-inorganic hybrid materials. They exhibit a variety of shapes and sizes on the basis of which they're classified into different types of clusters like Kagan, Strandberg, Anderson, Evans, hexamolybdate, heptamolybdate, octamolybdate, and so on. They are relatively stable, and their main attractive feature is their redox capability, like they are strong electron acceptance, and they have also transfer abilities. This feature allows them to form different kinds of derivative via coupling with metal or organic groups. Coming to their properties and applications, out of all the materials, why we are choosing POMs? Basically because they are diverse in terms of their composition, structure, nuclearity, and charge. Since they're composed of both metal and heteroatom, we can always play with them and we can tune the charge and stability according to the application we are looking for. So they find a variety of application like catalysis, antiviral, anti-cancer, photocatalytic degradation, anti-Alzheimer, antibacterial. First of all, we had purely inorganic POMs, but they suffered from few disadvantages. Like in long term, they have a high cytotoxicity, they have a low hydrolytic stability, low selectivity, and they're toxic to normal cells. So right now, the research focus is shifting from the pure POMs to functionalization of the POMs, by which we can solve the overcoming disadvantages. While COVID-19 pandemic, we all are sure it claimed millions of lives, one disease that we are silently suffering from is cancer, and the need of the hour is to combat it. Giving a background of my research, in our lab previously we have worked on a phosphomolybdate based hybrid solid, which showed anti-cancer, and it was highlighted in various media platforms. But we faced some disadvantages there, like we were not able to show the cellular optic studies, and we were not quite sure about the mechanism by which our synthesized POM was showing the anti-cancer activity. So in the present work, we tried to overcome all those limitations. On digging into the literature, we found that there was already cisplatin, which are used as an anti-cancer agent, and it is widely used, but it has some drawbacks like acquired resistance and severe toxicity. So here we are using molybdenum because of its versatility. Now coming to the synthesis of how we are synthesizing the POM, it's a simple hydrothermal reaction. We are taking the metal salt and we are adding the ligand at 140 degree for 48 hours, and we are getting the crystals, white crystals. These crystals were characterized with a single crystal XRD, in which the asymmetric unit consists of two half octamolybdate clusters surrounded by three triethylamine ligands and water molecules, which when joined together by hydrogen bonding, they form an extended 3D network-like structure. We have characterized it by powder XRD. We have matched them with the single crystal XRD and the powder XRD pattern to ensure its phase purity. We have also characterized it using X-ray photoelectron spectroscopy, from which we can confirm that molybdenum is in +6 oxidation state. And from the oxygen 1s spectra, we confirm about the bonding between the metal and the oxygen. From the carbon 1s spectra, we confirm the bonding of carbon, 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 nitrogen, and nitrogen 1s spectra shows that the triethylamine nitrogens are in protonated state. The FSM images and TEM images show us that our synthesized form is in the range of nanometer and it is in capsule form. Also, we confirm the elemental composition by stem mapping from, like, as we can see, molybdenum, nitrogen, carbon, and oxygen. Coming to the anti-tumor activity, the normal cell line like L-line 295 fibroblast, normal fibroblast cell line was used to assess the biocompatibility, and it showed that up to 30% biocompatibility within the concentration range 100 micromolar, which is quite a good number. We use the cell lines A549, HEPG2, and MCF7 to assess the cytotoxicity, and we observe that as we go on increasing the incubation rate from 24 hours to 48 hours, our solid exhibited very good cytotoxicity against the cancer cell lines. Any compound to be used for biomedical, we have to check its stability in physiological conditions. So for that, we went to check on the UV visible spectroscopy of our solid in PBS buffer at pH 7.4. And we observed that after 72 hours, there was no disappearance of no peaks, there was no appearance of peaks, and there was no peak shift, which indicates that the structural integrity of our synthesized form is maintained till 72 hours, which is a criteria for any material to be used for biomedical applications. Now we went on to check the mechanism by which our solid might be showing the anti-cancer activity. Our first intuition was to check DNA binding. So we went to study the ctDNA binding study of in the presence or absence of ctDNA, and we observed that there was hyperchromisms is seen, which gives an evidence of groove binding. That wasn't enough. Then we went on to check whether actually we can give any biological evidence that actually DNA damage is the reason behind the anti-tumor activity. So we went on to check the DNA fragmentation assay, and to our surprise, we found that the control line, which is the untreated, like the synthesized form is not added in the control line, it is showing the highest intensity band. And as we are treating the solid with the plasmid DNA, the intensity gradually goes on decreasing after 1, 2, and 3 hours, which shows that our synthesized solid is actually causing the DNA damage. As DNA damage is one of the main stimuli that induces apoptosis, so we can say that DNA binding could be the plausible mechanism for the anti-cancer activity. We went to check the cellular uptake, whether our compound is being taken up by the cell. The first picture shows the staining without our material. The second picture shows our material with rhodamine staining. And the third picture shows the merged image. That means our solid one, that synthesized form, is taken up by the cell, which gives an evidence that our synthesized material, being in the nanonage and being in the shape of a capsule, goes inside the cell, damages the DNA, and that's why it shows anti-cancer mechanism. The POM-based inorganic, we have chosen that POM-based inorganic-organic hybrids because they have a better cell penetration, they have an increased selectivity and decreased toxicity. So we can use that to optimize cellular targeting. In summary, we have synthesized a POM-based nanocapsules, we have characterized it, and we have checked its stability, we have checked this anti-tumor activity and biocompatibility also. We have checked the mechanism by which it is showing the anti-cancer. We checked the ctDNA binding study from UV visible, and we went on to check the cellular internalization. We confirmed the cellular internalization from cellular uptake experiment, and we also use the DNA fragmentation assay, which confirms the DNA damage. So I want to acknowledge ICHE for providing me the opportunity to present my research work. My thanks goes to my supervisor, Dr. Monica Singh, my lab members, my collaborator in Department of Science and Technology, and INST. This is our lab overview, what we basically do in our lab. This is my lab. Thank you so much.
Thank you, Shobna. Anyone? Going on.
Shobna, I have one question.
Good.
How have you taken the cell lines? Where did you take the cell lines for lung cancer? And
Ordered them from NCCS Pune from cell repository.
Okay, and you maintain them?
Yes, yes, ma'am.
You have all the
ma'am.
facilities to maintain these cell
Yes,
lines?
ma'am. Yes.
Okay, okay.
Yeah, please go ahead.
We were actually concentrating on at physiological condition. So we checked at pH 7.4. We wanted to mimic the physiological condition actually. So that's why we checked that one pH. Yes, yes. And we also check the water solubility. I have not shown the data. It's soluble in water also. What is the characteristics for a drug to be used for biomedical?
छोटा सा क्वेश्चन है बस मेरा, हाइड्रोथर्मल टेक्निक यू मेंशन, क्या हाइड्रोथर्मल किस प्रोसेस से किया था? हाइड्रोथर्मल का जो
Oven, sir. Hot air oven.
हॉट एयर ओवन में
Yes, sir.
you conducted this and you
Yes,
were
yes, yes.
able
We
to
are
obtain.
taking the ammonium molybdate salt.
See,
Then we are adding the ligand, H2O and DMF. We are
not
setting.
normal hot air oven?
Yes, yes, sir.
That's good.
It's programmed, like temperature programmed it is.
Programmed hot air oven with a
Yes.
variation in
Yes,
temperature.
we have to just set the temperature and the time. Then the reaction will occur and we are getting the white
And this
crystals.
reaction is, means you can carry out it in normal air conditions, like in atmospheric conditions.
No, no, sir. 140 degrees Celsius, 48
Fine,
hours.
fine. But what about atmosphere? Was it nitrogen or
No, no,
room
no, sir,
temperature?
nothing
That
like
is what I'm
Huh.
talking. Room temperature. Check. Right, Shubha. Thank you so much. So, right. So next we have Vishakha Chaudhary. Yeah. Vishakha ji will be presenting on gold nanoparticles. Right. Please go ahead.
Myself, Vishakha Chaudhary. I am working as a research scholar in the Banasal Vidyapeeth from Jaipur. And my research topic is the quantitative insights into gold nanoparticle-based drug delivery system for QSAR advancement in the era of artificial intelligence. As we know, cancer remains a major cause of death worldwide. There are many treatments to cure the cancer, but the biggest drawback is that they destroy healthy cells along with the cancer cell. So, to overcome this problem, we need a target drug delivery system that selectively target the cancer cell and greatly needed to design a drug delivery vehicle that can release the drug at control rate to maintain the therapeutic concentration for longer period. Therefore, nanoparticle-based drug delivery vehicles can be used as a target drug delivery system due to their high surface area volume ratio and the range of the nanoparticle from 1 to 100 nanometer. Along with the different inorganic nanoparticles, gold nanoparticle have based drug delivery system have observed to be safe for in vivo use due to their properties like inertness, biocompatibility, less cytotoxicity, biodegradability, surface plasma resonance, intrinsic fluorescence. As we know that bare gold nanoparticles are not stable, so to increase the stability of the nanoparticle, these nanoparticles can be surface functionalized with different carbohydrates such as glucose, fructose, sucrose, and starch. Carbohydrate coated gold nanoparticles have observed to good biocompatibility, which makes them suitable for target drug delivery system. The chemical reduction method has been performed to synthesize the various carbohydrate coated gold nanoparticle. In this synthesis, carbohydrate behave as a capping as well as the reducing agent, and the confirm of the formation of the nanosystem UV visible technique is used. And the characterization are done for the formation of different various carbohydrate coated gold nanoparticle by UV visible spectroscopy, IR spectroscopy, and dynamic light scattering. The absorption spectra from UV visible spectroscopy have observed at around 540 nanometer. To confirm the synthesis of various carbohydrate coated gold nanoparticle, and the capping of the carbohydrate was used to analyze by IR spectroscopy. In this spectra, we have observed there is a shift change in the peaks, which confirm the successful capping of the carbohydrate on the surface of nanoparticle. The stability and the colloidal solution was analyzed by zeta potential, and the size of the gold nanoparticle was made useful for the target drug delivery system because they can reach the target site easily and minimize the side effects. Now, the quantitative insights into interaction of carbohydrate and the carbohydrate coated gold nanoparticle with biological molecules such as DNA and protein by isothermal titration calorimetry and the fluorescence spectroscopy. So first one is the isothermal titration calorimetry, which measures the heat released or absorbed in chemical reaction. Parameters obtained from the ITC are binding constant, enthalpy, entropy, Gibbs free energy, and stoichiometry. Second one is the fluorescence spectroscopy, which measures the fluorescence intensity, and the parameters obtained from the fluorescence spectroscopy is binding constant. Now, the detailed comparison for the interaction of thermodynamic parameter, pure carbohydrate and carbohydrate coated gold nanoparticle to know the effect of coating on the surface of nanoparticle. This was done by isothermal titration calorimetry and fluorescence spectroscopy. For ITC experiment, DNA was taken in a cell of the ITC and the syringe was filled by pure carbohydrate or carbohydrate coated gold nanoparticle to achieve a saturation at the end of titration. In fluorescence spectroscopy, DNA shows a weak fluorescent, then which is insufficient to study the fluorescence quenching mechanism. So we used ethidium bromide dye. Ethidium bromide dye is an intercalating dye which is used to study the intercalation of molecule in the DNA to know the quenching of the fluorescence of DNA ETBR complex. The concentration of the nanoparticle was varied by the complete quenching of DNA ETBR complex. So we have performed the fluorescence spectroscopy. Now moving towards the result, the interaction between the pure starch was done by ITC as well as the fluorescence spectroscopy. No binding was observed from the ITC as well as the fluorescence spectroscopy. Whereas upon coating on the starch on the surface of gold nanoparticle, the binding was shown. So we will confirm the coating on the surface of gold nanoparticle, they show the binding. Similarly, we have performed the similar studies for sucrose, pure fructose, and pure glucose, and the binding was not observed. But whereas coating on the glucose, sucrose, and fructose on the surface of gold nanoparticle, the binding was shown. So this is the profile for pure sucrose and sucrose coated gold nanoparticle, fructose, pure fructose, and fructose coated gold nanoparticle, sucrose and glucose coated gold nanoparticle. And the observed trend was for various carbohydrate coated gold nanoparticle with DNA are follows as glucose, which have shows a higher binding, and the starch which shows a similar binding with glucose, sucrose which shows the moderate binding, and fructose gives the least binding because of the keto group. Now the similar studies was performed of the pure carbohydrate and carbohydrate coated gold nanoparticle with HSA, and this is also done by isothermal titration calorimetry and fluorescence spectroscopy. So the interaction between the pure starch with HSA was done by ITC as well as the fluorescence spectroscopy. In this study, the HSA does not interact with the pure starch, so we have concluded that there is a negligible heat will be observed. So this is the profile for starch, and the starch coated gold nanoparticle shows the binding, and the complementary result was performed by fluorescence spectroscopy. And similar studies was performed for fructose, pure fructose, and fructose coated gold nanoparticle shows the binding. This is for sucrose and sucrose coated gold nanoparticle. This is for glucose coated gold nanoparticle. And the trend of binding of various carbohydrate coated gold nanoparticle with HSA are shown as the highest binding will be shown by the starch, then fructose, glucose, and the least binding shows by sucrose. Now to calculate the therapeutic efficiency of synthesized nano formulation, the drug loading study have been performed with 5-fluorouracil anti-cancer drug. And the trend was observed for the therapeutic efficiency is starch and glucose give the similar therapeutic efficiency. The drug loaded starch and glucose have approximately same, then fructose, and the drug load sucrose coated gold nanoparticles is so least loading. Thank you.
Thank you, Vishakha. Questions?
Vishakha, I have one question. You said that you have done characterization, but did you do optimization also of these gold nanoparticles?
No, ma'am, not now.
You have not reached that
Yes,
stage,
ma'am.
but you will be doing it later?
Yes, ma'am.
Okay.
विशाखा
Yes, sir.
यूनिवर्सिटी ठीक है, बनस्थली बहुत अच्छी यूनिवर्सिटी है
Yes, sir.
है ना? एरोप्लेन चलाना भी सिखाते हैं वहाँ पे,
हाँ,
है ना? विशाखा बाकी सब तो ठीक है, जो लाइन में लिखा हुआ है इन द एरा ऑफ एआई, ये आर्टिफिशियल इंटेलिजेंस ही है।
Yes, sir. Basically, हम ना सर
मुझे प्रेजेंटेशन में कहीं एआई दिखा नहीं।
सर वो हम जो ट्रेंड शो कर रहे हैं ना वो एज अ QSAR एक तरीके से स्ट्रक्चर एनालाइज करके उससे की देख रहे हैं कि जैसे OH का ग्लूकोज पे क्या इफेक्ट पड़ रहा है, तो उसके अकॉर्डिंग हम वो काम कर रहे हैं।
हाँ वो ठीक है, लेकिन जब आप अब अगर यही बात है, जब आप प्रेजेंटेशन बना रहे हो तो जो आपने टाइटल लिखा है
यस सर।
वो दिखना भी चाहिए उसके अंदर, आपका जो पॉइंट ऑफ व्यू रिफ्लेक्ट तो हो। एआई आपने बहुत सारा काम कर रखा है, नैनो पार्टिकल्स बहुत सारे बनाए हैं, मॉलिक्यूल्स भी बहुत सारे उनके साथ अटैच कर दिए, लेकिन जो आपने टाइटल रखा है QSAR एंड एडवांसमेंट इन एरा ऑफ एआई, तो दैट वाज अ वेरी यूनिक थिंग एंड आई वाज वेटिंग कि कुछ एआई का एंगल से मुझे कुछ नया चीज दिखे। तो अपने प्रेजेंटेशन को नेक्स्ट टाइम जो टाइटल रखा है उससे थोड़ा सा मैच करने की कोशिश करो।
ओके सर,
ऑल द वेरी बेस्ट।
थैंक यू सर।
Right. Next we have an undergraduate student, Jasmine Kaur Sachdeva.
Good evening, everyone. I am Jasmine Kaur, currently pursuing biochemistry from Deshbandhu College. Today, the aim of my presentation is reviewing the functions of readily mesosporous silica nanoparticles in various inflammatory diseases in humans. Basically, nanoparticles have various applications in every field like medicines, electronics, and energy. Due to their various applications, they can even be used as diagnostic tools. Nanoparticles can be categorized into various categories based on their appearance, classifications, and sizes. They can be metal nanoparticles, ceramic nanoparticles, and semiconductor nanoparticles, and many more. Modern nanomedicine focuses on drug delivery at specific site more effectively and efficiently. For this, the most suited nanoparticles are the mesosporous silica nanoparticles. Mesosporous silica nanoparticles, because of the unique properties like tunable morphologies, mesopore structures, and biocompatibility and simplicity in their functionalization, they can be used in drug delivery and high and significant release profiles of the drug. Based on the type of pores, they can be categorized in various categories like unimodal, bimodal, multimodal, and hierarchical structure. RMSN being a part of the hierarchical structure, they have gathered a significant interest in the field of nanoparticles because of their structure. They have a radially wrinkled structure, that is, their primary mesosporous silica structure arranged in radially manner. Radially mesosporous silica nanoparticles basically have wrinkled sheets that arrange themselves in a spherical form, and the vacant spaces between the wrinkled sheets act as pores and used for drug loading. There are various biomedical applications of radially mesosporous silica nanoparticles. One of the applications are they can be coated with dexamethasone, that is a glucocorticosteroid, and used in the treatment of rheumatoid arthritis. In this research, we find they concluded that RMSN, when coated with the dexamethasone, have high loading capacities of about 76 weight% then compared with the other nanoparticles, that is SBA15 mesosporous nanoparticle. The drug loading efficiency was twice of RMSN compared to other nanoparticles. And also for the release profile of the drug, they found that the dexamethasone released from RMSN have initial have initial burst period at 20 hours, whereas for SB15, it was at 40 hours. Initial rates suggested that SB15 is a better carrier for the dextromethasone, but at the later stages, the dextromethasone released from RMSN at a consistent and steady rate till 100 hours, whereas in SB15, it attained a plateau region after 60 hours. So the RMSN release profile was also 2.3-fold better than the SB15. The other application of RMSN is they can be amine functionalized and can be used to coat anionic drugs like ibuprofen. And it can also be made pH and temperature responsive so that they can have a sustained drug release, and they have a sustained drug release and can increase the drug loading efficiency and can even be given orally like other silica nanoparticles. RMSN, because of these applications, can be used to monitor can be used to deliver drugs in many inflammatory disease like inflammatory bowel disease. Inflammatory bowel disease is basically a chronic inflammation in the digestive tract. There are various symptoms of inflammatory bowel disease that can be abdominal pain, rectal bleeding, diarrhea, or anemia. There are many reasons for this disease. They can be genetic, environmental, or even immune system dysregulation. There are many treatments that are used in inflammatory bowel disease, but one of the most effective treatments are corticosteroids. Corticosteroids are used to lower down the inflammation, and there can be various corticosteroids that can be used to administer in inflammatory bowel disease. They can be budesonide, prednisone, hydrocortisone, methylprednisolone, with loaded with RMSN. No. Radially mesosporous silica nanoparticles can be coated with the drug and can be given in inflammatory bowel disease. So basically, till now, there is no scientific finding. There is no scientific finding of the RMSN in inflammatory bowel disease. So we can use it in inflammatory bowel disease with the appropriate corticosteroid, as it has various applications in both drug loading capacity and the release patterns. These are my resources, and this review was possible under the guidance of Dr. Vinita Kashyap. Thank you.
Thank you, Jasmine. Anyone? Jasmine, second last slide देखने को मिलेगा दोबारा? Basically, you presented a review, right? 11th, yeah. There are no scientific findings. बस ऐसे रहने दो, मुझे बस एक मिनट read करने दो क्या. Use of radially in the treatment of inflammatory bowel disease. So, regarding the use of, that means, I didn't get this line because your title says that the use of these nanoparticles in
Inflammatory
disorders
in humans. So inflammatory bowel disease is basically an inflammatory disorder only.
Yeah,
So-
but you say there are no scientific findings. What are you trying to say over here?
Basically, it's a proposal that we can combine RMSN with the appropriate drug and use in inflammatory bowel disease.
So that means it has not been done as yet.
No, sir.
Okay, so this is not a confusion.
Sorry, sir.
मैं confused हो गया. Fine, ठीक है. Thank you, Jasmine. It's good. Thank you. Congratulations. Undergraduate बच्चे अगर ऐसा research और में ध्यान देंगे तो it's very good for the future, right? So next we have Anisha. Anisha, we don't have it? Fine. So next we have Harsha Haridas, a PhD research scholar, and She has worked on green coffee leaves. Great.
Shall I start? Namaskaram. Warm greetings from God's own country, Kerala. Myself, Harsha Haridas, doctoral student of Department of Physics of National Institute of Technology, Calicut, Kerala. Here, my topic is green coffee leaves, an active functional ingredient towards particle engineering and antibacterial applications. I'm excited to talk to you before because part of this work has been published in Nature Scientific Reports. So, next. Okay. So, excuse me, the second slide is in hide mode, I think. No, this is the third slide. Yeah. Oh, second. No. Yes. So, before entering to the deep topic, can I ask a question? Have you ever considered our chemistry, the science of transformation, is playing a dual role? Act as a doctor as well as a destructor to nature? I think yes, right? One side, the chemical progresses are crucial to the age of our nature, right? The second side, whatever impacts it is getting into the nature, we are trying to solve through chemistry itself, right? So the solution is through green chemistry. So according to UNO, green chemistry is designing, developing, and implementation of environmental benign or eco-friendly chemicals in our reaction pathways. So by following the green chemistry protocols, we can nullify the effects of chemical synthesis, and at the same time, we can add the benefits like it will give us zero waste, non-toxic. We can save the energy. At the same time, we can minimize the use of toxic chemicals in our labs. One of the raised questions during nowadays is increasing the antimicrobial resistance in existing medicines. The answer is also chemistry, right? So we have to find a green remedy to nullify that antimicrobial resistance. So we have to find a green remedy in the part of green. We have to find a green nanoparticle solution which showing antimicrobial resistance. So finding through the literature review, we have found that there are more than 1,000 papers in the field of green synthesis based on tea leaves. But we can't see based on coffee leaves. A recent literature which shows that coffee leaves contain comparable amount of phytochemicals as that of its beans. So researchers are concentrated on beans, even though it is seasonal as well as costly. The phytochemicals present in coffee beans have utilized for nanoparticle formation. There is no researches have done based on coffee leaves. We can see these are the top 10 states, top 10 coffee producing states in India. So the availability of coffee leaves are more than coffee beans. It is non-seasonal, there is cost effective too. So if the farmers are facing a issue due to these seasonal crops, we can aid as economical background by developing a new sustainable development subject like adding a coffee leaves towards particle engineering. So we know that as per our distinguished chief guest told, we have to go through our nature and our culture, which have already used phytochemicals of our plants as Ayurveda, etc. So these coffee leaves have already existing success stories as use of ethnomedicine, tobacco substitute, organic fungicide, etc., but never used for particle engineering. So our thought is, our hypothesis was to prepare noble metal nanoparticles with the use of coffee leaf extract as a reducing agent, stabilizing agent, as well as capping agent without any use of toxic agents. So from the phytochemical screening, we have came to know that 5-CQA, this 5-caffeoylquinic acid is the abundant phytochemical present inside the coffee. And we can go through a simple technique like mixing up of leaf extract is as with that of the metal solution, and we can prepare the nanoparticles within minutes. Okay. From here, we can see the methodology. That means the Here we can see the mechanism behind the formation of nanoparticle. We have discussed the mechanism behind the formation of noble metal nanoparticles through the coffee leaves, and treating the 5-CQA as the fundamental agent behind the reducing agent. We can see that the oxidized quinones are acting as a factor behind reducing agent, which is converting the metal ions to metal nanoparticles. And the same carboxylic acids of the 5-CQA is binding on the surface of the nanoparticle surface, which acting as a capping as well as stabilizing agent for the nanoparticle which is synthesized. So we have performed the UV visible analysis and other characterization from the colorimetry confirmation. Like here we can see the plant extract is in light yellow color, and silver nanoparticle is in dark yellow color, and gold and silver biometallics in golden yellow color, and purple color is in goes to AU nanoparticles, and corresponding surface plasmon resonance peaks are visible in the UV spectra. And we have performed the particle size and stability analysis. A most excellent result we came through the theta potential. We got more than -30 millivolt, which shows excellent stability for the green prepared nanoparticles. So it gives it shows that the coffee leaf, we can replace the coffee leaves as a chemical agent. So the X-ray diffraction scattering analysis was were excellence towards towards the chemical nanoparticle, and the transmission electron microscopy analysis reveals that we can synthesize clearly spherical uniform nanoparticles, and here the bimetallic nanoparticles are showing core shell as well as alloy structure. And through the application field, we have gone to perform two antibacterial studies for silver nanoparticle as well as bimetallic nanoparticle, which has utilized coffee leaf extract, and we got more antibacterial result, efficacy results towards bimetallic nanoparticle, which can be considered that during the bimetallic nanoparticle formation, the synergetic effects helps these nanoparticle to fight against the pathogens like gram-positive as well as gram-negative bacteria. So, in conclusion, without any chemical external agents, we have performed the green synthesis of silver, gold, as well as silver and gold bimetallic nanoparticle in in situ lab performance itself. Within minutes, we can confirm visually as well as spectrally the all nanoparticle formation, and size as well as stability effect shows that this will be a crucial towards developing sustainable applications in the field of material science as well as biomedical area.
Right.
Thank you.
Thank you, Harsha. Anyone? Questions?
We have two types of size distribution. The first is hydrodynamic size distribution through DLS. We can see that hydrodynamic diameter coming from 64 for silver, 87 to 90 for gold. For bimetallic, it will be 174. And using term, it is like 28 for silver and 12.5 for gold and 18 for bimetallic nanoparticle. So it gives excellent result. Yeah, in situ synthesis.
Good. Harsha. Yeah. You mentioned in your synthesis process that you left it for 24 hours. Yeah. In the synthesis process.
We have to confirm whether any changes are occurring or not. So we have to keep it like.
Okay, that is what I was.
We have to.
Why did you leave it for 24 hours?
No. Sir, that means there is no further change. So until we have to confirm whether any changes are happening in the spectra.
Right. And one thing that you mentioned in the conclusion part, 7th slide, Pajao. Yeah, you mentioned, development of antibacterial food packaging.
Yes, sir.
So, did you attempt anything like what is the efficiency of this, or will you be trying about it?
Actually, our next work is.
Next work will be the application of this.
Active packaging.
Because if I see in your work, coffee in itself doesn't have any bacterial scope. It's not acting as antibacterial. The coffee part.
Yes, sir.
It's not.
No, extract itself is showing no antibacterial efficacy.
Antibacterial efficiency.
Yes.
So when you are making a nanoparticle, so how much will it be means efficient enough in comparison to the present antibacterial what you call material that is existing? So
we have compared with tea leaf based nanoparticles, sir. So the bimetallic nanoparticle is showing better antibacterial efficacy.
Then the tea leaves are.
Yeah, that work is under communication.
It's in the future scope, so you can
Yes.
very well do it.
Yes,
Right.
sir.
Thank you. Thank you.
Thank you, sir.
Fine. So we have very interesting, what do you call, papers being presented, and most of them are very relevant to our environment and the present situation that we are in. So next we have a undergraduate student, Khyati Chaudhary. Yeah, please go ahead.
Good evening, everyone. I'm Khyati, and my topic for presentation is distribution and temporal variation of total volatile organic compounds and their concentration related to the health risk in the state of Punjab, India. The main objectives of my study include to determine the sources of VOCs, BTEX, which is a class of VOC, and to evaluate the data of BTEX over the course of 3 years, post-pandemic, pre-pandemic, and during pandemic. We are also going to calculate the health risk related to BTEX. Introduction. Okay. So as everyone knows that in 2019, Wuhan, China, COVID was first discovered. and due to its rapid transmission rate, it was soon declared as a global pandemic, which possessed very high to severe threats. Many nations implemented lockdown measures, including India, and this led to shutdown of many industries, vehicles, and automobile industries. The air pollution is the environmental contamination which is caused by physical, biological, and chemical agents that can alter the characteristics of atmosphere, and obviously it has both very harmful and detrimental effects. But due to the lockdown, the air quality significantly improved because the air pollution was reduced. The sources of air pollution there are many, like SO2, CO2, NO2, and PM. But for our today's study, we will be focusing on VOCs, volatile organic compounds. What are volatile organic compounds? They are the class of organic compounds that are essential for the formation of secondary aerosols, photochemical smog, and ozone. VOCs have both anthropological and natural sources. Well, the anthropological sources can be cigarette smokes, motor cars, petrol evaporation, and even has natural sources, which includes agricultural release, biomass burning. And they are neurotoxics, genotoxics, mutagenic, so harmful, and are so easy to come in contact of humans just by breathing. The class of BTEX stands for benzene, toluene, ethyl benzene, and xylene. And they have wide variety of emission sources. The disorders that are linked to BTEX exposure include cancer, depression, respiratory conditions, and circulatory system disorders. Benzene is also classified as group 1 gaseous air pollutant, which is carcinogenic in nature. So for our study, we have included Punjab, which is a state in India, northern India. And due to the availability of data, we have basically selected 6 monitoring stations, which are Patiala, Khanna, Ludhiana, Mandi Gobindgarh, Amritsar. We have obtained our information from CPCB website, Central Pollution Control Board, Delhi, India. This is the map of all the monitoring stations that we have selected for the study. The methodology involved was quite simple and effective. It basically involved the process of estimating potential harmful health consequences on people who may be exposed to these contaminants. This is also called Human Health Risk Assessment, HHRA. And to evaluate the carcinogenic part of our study, we studied the LCR, which is the lifetime cancer risk. It includes only 3 basic steps, which is the hazard identification, just identifying the VOCs, exposure assessment, we are calculating the length, frequency, and the extent of human exposures of these VOCs. The risk characterization includes the probability of the exposure. As I have already discussed, our study is classified in 3 eras, which is pre-pandemic, 2019, pandemic, 2020, and post-pandemic, which included the year 2021. So the TVOC trends, which is the total volatile organic compound trends, were greatly reduced. Why? Because of the total and partial constraints on all the activities due to lockdown. Transportation activity, industrial activity, all were put to halt because of the lockdown, and thus, as already mentioned, it improved the air quality way much compared to the prior years of lockdown. The trend of average TVOC concentration was found at highest in Patiala, then in Amritsar, followed by Mandi Gobindgarh, Ludhiana, Khanna, and Jalandhar for all the 3 years. In comparison, if we need a figure, it's 43% decrease in TVOC concentration was recorded across all monitoring stations during the lockdown. And after lockdown, as there was resumptions of all activities, there was a 16% increase in TVOC's concentration. Patiala recorded the highest value because of the pharmaceutical industries and the biomass burning, while Jalandhar recorded the lowest. Specifically coming to the pre-pandemic year, the average trend for benzene, was found to be highest in Khanna, Mandi Gobindgarh, Amritsar, Ludhiana, Patiala, while for other VOCs like toluene, ethyl benzene, the trend was slightly different. But BTEX concentration was found to be highest in Patiala again. During the pandemic year, again, BTEX concentration was found to be highest in Amritsar, while the lowest was recorded in Khanna. From the table, it is quite evident how the concentration of each BTEX. Post-pandemic trend for average concentration of benzene included was found in highest in Mandi Gobindgarh, Khanna, Patiala, Amritsar, and Ludhiana. Again, the table shows the data, which is quite evident. To simplify it further, there is a graph which the blue lines represent Patiala, and you can see during all 3 years, the value for BTEX was found the highest in Patiala. So now the comparative evaluation. The benzene, the VOC concentration of benzene was reduced to 50% to the corresponding period in 2019, and it decreased by 8% if we compare it to the 2021 year. The level of VOC or toluene increased before lockdown and was decreased after it. The largest variations were observed in Patiala and Amritsar. Thus, the present study TB ratio, which is the toluene to benzene ratio, was found to be much lower in lockdown period than in pre-lockdown period. Now coming to the health risk assessment part, these as we know, the VOCs are widely dispersed and they both have carcinogenic and non-carcinogenic effects. Toluene and metaxylene have impacts on human health that are non-cancerous, while benzene and ethyl benzene have cancer-causing effects. These cancer-causing effects mean skin cancer, endocrine cancer, and nervous cancer. And the non-cancerous parts include kidney damage and chronic liver damage. The highest LCR values were found to be highest in Mandi Gobindgarh for all males, females, and children. Quite evident from the graph again, Mandi Gobindgarh recorded highest LCR values for both male, females, and children. Now to conclude my point, the TVOC concentration for all monitoring station in average was found to be from 8.9 to 1.80 before pandemic. It was reduced to 5.59 to 1.71 during pandemic, and further and it was again further reduced to 5.57 to 1.43. In the current study, the TVOC was observed to be higher for pre-pandemic periods, as it has been already mentioned many times. The LCR values, this is the new point, the LCR values were exceeded far more than what's prescribed by the CPCB for children. The purpose for this study was to record the significant difference in VOCs which is brought by COVID-19, which can be used in example for creating better air pollution policies and strategies. Thank you.
Thank you, Khyati. Questions, please.
Any questions?
You're from Deshbandhu College.
Yes, sir.
दो अपने friends तो लाके बैठाते कि मुझसे questions पूछ लेना, अच्छा हो
They are
जाएगा.
in the other hall.
तो यहाँ बैठाना था ना कि मेरे से questions पूछो तो.
They are presenting them there.
Khyati, this seems to be a very exhaustive work. बहुत सारा काम
Yeah,
किया है
it was. Actually, it's an ex-faculty of Deshbandhu College, Dr. Bhupendra Singh, who has helped me through all of this. This work has actually already been published in a very reputed journal, and me and my friend were acknowledged in the paper for it. So yeah,
Oh, in fact, I was about to say that you should have published it.
it is already published. It was published this year only.
Data कहाँ से लिया सारा मतलब
It was CPCB website.
CPCB
Baking
website
webs-
से
yes, sir.
depicted from
Yes,
the website
yeah.
से. Okay, this value जो ये third point लिखा है, like the LCR value for benzene was found to be higher in the children. ये कैसे means CPCB data तो पैरा उसके monitoring stations लगे हैं वहाँ से online दिख जाता है. But this is something biological.
Yes. Actually, the LCR values were calculated using Dr. Bhupendra sir did all the work, and I was just told to conclude it. Well,
Good.
and yeah, but that's a really good question. I think mainly all of his values were calculated from the website only. I'm really not sure about the method, but yeah, it was all the data is from CPCB website and other references. Actually, I have included references.
Right.
Yeah.
That is what means Bhupender.
Yeah,
right?
Dr. Bhupendra Singh.
Yeah, डॉक्टर भूपेंद्र को बोलिएगा कि रेफरेंस भी वहां पे डाल दें क्योंकि ये बायोलॉजिकल स्टडी था.
Yes.
ये डाटा पैरामीटर नहीं है कि
yes.
सेंसर ने डिटेक्ट किया और हमें पता लग गया.
Yeah.
तो उसका भी अगर रेफरेंस चल जाए तो इट्स ऑलवेज
Yes.
justifies the thing. Right. Thank you so much, Kathy.
Thank you, everyone.
Right. Next we have a researcher Rakhi Tyagi ji. Rakhi ji, do we have? Yeah. Another work on Punjab. Punjab पूरा रॉकिंग है. हाँ, सारा काम पंजाब पे हो रहा है आजकल. नहीं मैं पंजाब से नहीं हूँ.
Respected Chairperson, Dr. Rajiv Singh and Dr. Manisha Sengher, respected organizer, participants, and attendees, a very good afternoon to all of you. I will be presenting my work under the title Clay and Galactomannan based film, a potential food packaging material. Right now, I am working on a project, externally funded project in Indian Institute of Technology. And there are some other contributors from other institutes also. Now, let's go. Okay. Now, this is a layout of today's presentation. I will start with my starting material or raw material used, the guar gum, which was chemically modified. The modification processes were optimized in terms of the output, which was DS, degree of substitution, and derivatized samples were characterized by using spectroscopic method. The second material was clay, which was characterized but used as it is without modification. Using these modified guar gum sample and the clay material, the film were formulated, which were further subjected for their applications. Now, the guar was the research material during my PhD work. I have selected the guar because, as we know, India is an agriculture-based economy, and more than 60% of population is engaged in agriculture activity to earn their bread directly. Now, why I have selected guar? India is a major producer of guar gum, and India contributes more than 80% towards the global production of guar gum. And we are producing more than 5 lakh metric ton of guar gum annually from last 10 to 15 years. But the countries like China export the native guar gum and then formulate and make its product. And then we, the producer of guar gum, we export this, import this, and that's why the ICR was working on the value addition of guar gum. So the clay material, India is a climatically diverse country, and there are availability of different clay materials across the globe also. And right now I am working on the clay material for the formulation of cementitious material also. Now, why the chemical modification of galactomannan, guar galactomannan? Now, the modification is opted for to target two properties. The first one to introduce the desired characteristics, and the second one to overcome the undesired one. Now, it is a natural polymer. There are several undesired characteristics like uncontrolled rate of hydration, insoluble impurity, biodegradability, etc. So there are numerous methods for the chemical modification, but based on the group introduced during the modification, broadly, the modification is categorized in three categories: the cationic modification, the anionic modification, and the neutral. For this study, I have carried out the cationization via quaternization, anionic modification by carboxymethylation, and the neutral treatment was simple alkali. Now, I will go into this is a basic scheme for the chemical modification of guar gum under the under the catalytic activity of sodium hydroxide. Now, the first step is the production of alkoxide form of guar gum, followed by its reaction with etherifying reagent. It may be, it was CHPTAC, and the present study carboxymethylation, this was sodium monochlorohydroxide. Now, for the quaternization reaction, I have already published a paper which details on the optimization reaction condition towards the quaternization and its spectroscopic characterization. Now, as output of this study, we obtain a DS of 0.45, which is a measure of efficiency of the reaction. Now, these are the parameters which were also studied for the carboxymethylation process, concentration of alkali, reaction, and all that. Now, this is the process for the carboxymethylation process. This calculation of degree of substitution of, now these are graphs for the concentration of reagent. This is for temperature, this is for gum-liquor ratio, and this is for the reaction time. Now, these as an output of the reaction, the optimized reaction condition was obtained and a maximum DS of 0.58 was acquired. Now, the derivatized sample, carboxylated, and the native sample were subjected to the structural characterization by using FTIR method. As we can see, there is an introduction of there is an introduction of peak, additional peak at 1590, which is the indication of introduction of carboxyl group. Now, this is protons NMR spectra of native and carboxymethylated sample. As we can see in the native sample, there was peaks were concentrated in an anomeric and ring region, but in the derivatized sample, an additional peak was identified at 3.1, which was accounted for the introduced carboxymethyl group. Now, this again the 13C NMR spectra. Here is additional peak due to the introduced carboxyl group. Now, this is DEPT13 spectra for the native and modified sample. Now, this is HSQC spectra of the native guar gum. Here again, the peaks were concentrated in the ring region and the anomeric region. In the derivatized sample, the peaks were due to introduced group was not resoluted as it got merged with the ring region peaks. Now, these are selected clay sample. As we can see, the colors of the selected clay sample is very different, which is also reflected in their chemical composition. The XRF data for the selected sample. I have marked the major component, which are about 30%. The sample Siddha was rich in iron. The Khera was rich in alumina and silica. The Simaria sample have all the alumina, silica, and iron in comparable amount, while the sample termed as olive was rich in silica. Now, this is TGA curve of the selected clay sample. As we can see, the TGA curve of Siddha and Simaria shows a peak at between 200 and 300 degrees centigrade. which is due to the gothite, as we have already seen in the XRF data. These two samples are rich in iron. Now, the last one sample, olive, showed a peak below 2000 degrees centigrade, which is a characteristic of spectite clay material. Now, for the present study, we divided our factors for the type of polymer we are using. It was native, carboxymethylated, quaternized, or alkali treated. The B was quantity of clay material used. The C was the clay composition, different clay based on its composition, and the formulation temperature. Now this is the layout. I have used the statistical design. As we can see here, based on the selected factor and their level, L16 design of experiment was selected. Now this is the method for the formulation of clay and polysaccharide based film. Now these are formulated film from using different clay samples. Till now I have formulated 12 films, and this film A4, B4, C1, D3. A stands for the alkali treated guar gum, B stands for the 2.0 milligram of clay sample, C indication sample which was silica and alumina rich, and the D one is the. This film showed promising properties which can be further explored for food packaging application. This is flexible and easy to work with. As we know, guar gum film got break on when water gets evaporate from these samples. Now the 4 sample is also, I am working on this. Now the study ongoing. I am also looking into the antioxidant activity and a deeper look into the process we can improve, and the formulation of film in a larger size, and also the biodegradability and durability. Now these are the researcher contributed to this work directly or indirectly. Now that's, thank you.
Thank you, Rakhi. Once again, the forum is open. Anyone who would like to ask something or any query or curiosity, film की photo भी डाली है इन्होंने. The best part. Generally, people are presenting their work, but they are not showing what exactly they have produced. But I really like that you've shown those films.
Thank you, sir.
Anyone? No, your work is good, and I like the packaging.
Sir, right now I am looking for if there is some lab, because I am working in a project, and project is based on clay material formulation. There is no facility for the food application part. So I am also open for the work if there is some
किस
lab.
डिपार्टमेंट में IIT में कहाँ पे काम कर रहे हैं?
IIT में material research laboratory.
केमिस्ट्री डिपार्टमेंट में.
No, it's material. We are it is basically
Alak-
civil work. They are formulating cementitious composition from this clay materials. That's my PhD was on the polysaccharide. Now I'm working on clay that I.
Right. The work was indeed very good, and the films that you have created are, produced are very good, and I hope you are able to apply them in public domain.
Yes, sir.
So did you try for any of these things? Public
Sir,
domain,
right
like
now there is a constraint due to the laboratory, because they are working in the cementitious composition. So there is.
so the lab का problem है ना, means अगर department promote
No.
करे या IIT promote करे or any
No,
of the institutes that you are
I'm
working
working
in,
on an externally funded project, sir. So
externally DST का होगा, DBT का होगा.
no, it is a Switzerland funded project.
अच्छा.
That's-
So you need permissions from them.
Yes,
then.
yes.
तो issues हैं. ठीक है.
Thank you,
Thank you so much, Rakhi. All right, and next we have a PhD scholar, Asa Tomar. And she'll be speaking on firework festival at Diwali, Taj Mahal. ये पटाखे पक्का बंद करवाएंगी अपनी स्टडी से, हैं?
Good evening, everyone. Myself, Asta Tomar from Dr. Bhimrao Ambedkar University. Today I am here to present my topic, study of fine particulate pollution during firework festival Diwali at World Heritage Site Taj Mahal, Agra. Okay. Introduction. So according to WHO, urban population is routinely exposed to severe episode of air pollution, which rises during the high impact event like Diwali celebrations. And what Diwali is celebrated across India for the return of Lord Rama to his kingdom after 14 years of exile and subsequent victory over the mighty devil king Ravan. Firecracker basically contain very different kind of pollutant which affect the health of ones. After bursting, firecracker release different size of particle ranging from non-inhalable to inhalable and ultra-fine particles also. And the concentration of PM 2.5, concentration of PM 2.5 concentration of PM 2.5 and ultrafine particles are of utmost concern because of their size and greater interactive surface area with respect to their mass. Also, the festival is concurrent with the onset of winter season, which increases the pollution concentration with creating stable environmental conditions, such as low temperature, calm wind conditions, occurrence of nighttime inversion, stable atmosphere. So the burnt firecracker reach up to the alveolar sac by the way of penetrating deep into the lungs, where they get transported to other organs through blood circulation and cause systematic poisoning. And fine particulate pollution primarily cause asthma, COPD, lower respiratory infections, allergies, and even death in extreme cases. And PM 2.5 consists various heavy metals, which also cause various type of diseases. An objective of the study is basically to determine the effect of firecracker during the Diwali festival on methodology. This is the sampling site near Taj Mahal. I've done sampling near the south gate of Taj Mahal, which is basically a residential area. I've done the sampling with fine particulate sampler APM 550, and sampling is carried out on the rooftop of the site with a vertical height of 10 meters from the ground level. And each of the sample was collected on quartz fiber filter paper. This is the methodology. First, I have marked the identification number on the filter paper. Then I pre-bake the filter paper in muffle furnace for 3 hours at 900 degrees Celsius. Then I have conditioned the filter paper for 24 hours. Then record the initial weight of the filter paper and placing the filter paper and running the sampler for 24 hours. Then removing the filter from the sampler and conditioning again the filter paper in the desiccator, and then recording the final weight of the filter paper and calculating the mass concentration of PM 2.5. Then gravimetric analysis. Then now comes the observation. In the study, I observed that the concentration of PM 2.5 significantly increases during the whole study period. I've conducted the study into 3 phases, which is pre-Diwali, Diwali, and post-Diwali. And we can see that the concentration is above the standard limit given by NARCS and subsequently increasing with the days. 24-hour average concentration of PM 2.5 average concentration is increasing in the terms such as pre-Diwali में सबसे ज़्यादा थी, after then Diwali, then post-Diwali. Reason behind the significant rise in the concentration during the study period is first the bursting of firecrackers, and second one is the meteorological variation in the meteorological parameters at the sampling site. And also, as I said earlier, the festival is concurrent with the onset of winter season, when ambient temperature greatly falls due to infiltration of northern Himalayan cold front winds, which creates stable atmospheric conditions. And furthermore, nighttime drop in the air temperature coupled with the decrease in mixing height, which ultimately forms the inversion layer near the ground, trapping the pollutant near the ground level. And next, I also recorded the meteorological parameter
And as you can see that the temperature, wind speed specifically decreased during the post Diwali time period, which result in the highest concentration during the post Diwali period. And I've also performed the correlation between PM 2.5 temperature and wind speed, which also showed that PM 2.5 is strongly negatively correlated with the wind speed and temperature. So dispersion of the pollutant is atmosphere is greatly affected by meteorological parameter as they control their dispersion and dilution in the atmosphere. And to understand the influence of meteorological parameter on particulate emission, Pearson correlation coefficient is applied to the data set, and temperature shows this strong negative correlation with PM 2.5, which state that low temperature enhance the pollution concentration, and temperature shows positive correlation with wind speed, suggesting that low temperature result lower wind speed, which will lead to the stagnant static atmosphere, which favor accumulation by limiting dilution and dispersion, and enhance longer residence time for of particulate aerosols in the atmosphere. Further, wind speed also showed negative correlation with PM 2.5, which state that low wind speed facilitate the accumulation of pollutant near the ground level, as low wind speed will result in lower mixing height, which in turn restrict the movement of pollution in the vertical direction. And the post-Diwali saw the highest concentration, which is attributed due to the lowest wind speed recorded during the study period, which is 1 km/h. As after Diwali, the busted firecracker pollution remained suspended for a longer residence time in the atmosphere, which inhibited particles' vertical movement and caused them to suspend close to the ground for a longer time. Conclusion of the study is that during the study period, fine particulate were found more than twice the standard limit given by NAAQS, and firecrackers were responsible for the elevated concentration during the study period. And firecracker contain and discharge a variety of toxic elements which reach to the breathing zone and penetrate deep into the lungs, causing asthma, COPD, cardiovascular diseases, and allergy in the urban population. And in conclusion, the study shows that mass community is more prone to the compound emitted by firecracker during Diwali, and hence there is immediate need for stringent regulatory standard regarding the present use of firecracker and production and uses of green cracker in the future. Thank you.
थैंक यू आस्था। अब पूछने की जरूरत है या खुद ही पूछो? व्हाई नॉट, वी आर वेटिंग फॉर यू।
Yeah. Actually, NEERI is working on that. CSIR NEERI is working on that. और उन्होंने काफी सारे such as स्वास, स्टार, ग्रीन क्रैकर्स बनाए हैं जो कि 30% पोल्यूशन, स्पेसिफिकली पीएम पोल्यूशन जिस पे मैं काम कर रही हूँ वो कम करते हैं, लेस 30% पीएम पोल्यूशन जो हम नॉर्मल फायर क्रैकर्स यूज करते हैं उनसे। वो उसमें पोटेशियम नाइट्रेट का यूज करते हैं जिससे कि वो पोल्यूशन को लेस डाउन कर देते हैं एज एन ऑक्सीडेंट। आई हैव डेटा, मतलब मैं समझी नहीं, मतलब मैंने ये अपने डेटा सेट्स पे ही परफॉर्म किया है। ये मेरा खुद का मतलब मैंने ये काम किया हुआ है, ये मेरा खुद का वर्क है, इस पे ही मैंने परफॉर्म किया।
Anyone else? तो बेसिकली दिवाली पे पटाखे नहीं फोड़ने, बैन करवाने का प्लान है ना?
ग्रीन क्रैकर्स।
ये कौन से ईयर का स्टडी है जो आपने किया?
2022।
रेफरेंस 2013 का था एक, इससे पहले वाली स्लाइड में
सर 2022
एक 2013 का रेफरेंस था एक जगह। हाँ, बेसिकली ये मींस तब से लेकर अब तक में तो बहुत फर्क आ गया आई बिलीव। तो इसका रेफरेंस यहाँ पे, और फिर एक क्वेश्चन आता है जैसे यू सेड प्री दिवाली पोल्यूशन ऑफ PM 2.5 इज मोर एज कंपेयर।
नो सर, पोस्ट दिवाली का ज्यादा था।
ये सिग्निफिकेंट राइज इन द कंसंट्रेशन, नहीं इसी स्लाइड पे
सबसे कम प्री दिवाली पे था, उसके बाद दिवाली, देन पोस्ट।
उसी स्लाइड पे जाओ।
प्री दिवाली पोस्ट दिवाली।
प्री दिवाली हाईएस्ट दिख रहा है, नहीं या मैं गलत समझ रहा हूँ?
सर नहीं, मैं तो
मींस अगर हम एरो को देखें तो
हाँ,
है ना, मैं तो खुश हो गया था
नहीं
कि इस बार लगता है पटाखा फोड़ने का मौका मिलेगा। ठीक है, राइट, एनीवन एल्स? आपको ठीक, थैंक यू वासना। Right, and next we have the second last, I believe, Mansi Vats. She will be speaking on urea-assisted hydrothermally synthesized mesoporous tin oxide hydroelectric cell. Right.
Good evening, everyone. I'll be presenting on urea-assisted hydrothermally synthesized mesoporous tin oxide based hydroelectric cell. So hydroelectric cell is a green alternate source of energy which generates electricity by dissociating water molecules at room temperature without the use of any electrolyte, light, or electricity. So any material that has to be used for hydroelectric cell application must have three main characteristic properties. First, the material should be oxygen deficient. Second, it should have unsaturated surface cations, mesoporosity. So why tin? So tin is a material with low defect formation energy, high electron affinity, and it has reduced coordination surface of tin atoms, which makes it potential material for hydroelectric cell applications. So the methodology we adopted for preparation was we took first the mixture of tin, ammonium sulfate, and urea was with water and ethanol and stirred for 3 hours. Then the solution was transferred into an autoclave, and the hydrothermal treatment was done at two different temperatures, 90 degrees Celsius and 150 degrees Celsius, which was labeled as sample A and sample B, and then kept for 24 hours. The precipitates obtained were washed repeatedly with water and ethanol and then dried overnight, and then they were ground to fine powder and annealed at 400 degrees Celsius. Now, from the XRD data, these are the characteristic peaks which indicates the presence of crystalline tin oxide particles, and it was confirmed from JCPDS card number 01200657. The FTIR data depicts the peak at 455 centimeter inverse and 461 centimeter inverse corresponds to SNO vibration, and 592 centimeter inverse corresponds to SN vibration. And the peak which is observed in graph of sample A, which was around 3350 to 3415 centimeter inverse, it was of adsorbed OH of water molecule. So from this, we concluded the formation of tin oxide particles with high purity. This is the BET graph, and the both the graphs represent type 4 isotherm, which H2 type curve, which depicted the presence of ink bottle shaped pores. These are the FSM images which show the agglomerated particles, but the particles are of spherical shape. Now coming on to the formation of hydroelectric cell, how did we form it? So the sample we annealed earlier was pressed into pellets, and these pellets were sintered at 650 degrees Celsius, and then the pellets obtained were one face of the pellet was painted with the silver paint as cathode, and the other face was covered with zinc sheet as anode. Now to test the hydroelectric cell performance, VI plot impedance data was collected, and from the VI plot, it was observed that sample A, which was treated hydrothermally at 95 degrees Celsius, displayed a short circuit current of 18.7 milliamperes with a maximum voltage of 0.75 volts, and the sample which was hydrothermally treated at higher temperature at 150 degrees Celsius showed a better current at a short circuit current of 34 milliampere and a maximum voltage of 1.296 volts. As we can see in the VI plot, the graph is divided into three parts. So part A and B is the activation polarization loss. BC represents the ohmic polarization loss and CD represents the concentration polarization loss. From the impedance data, we obtained a single curve which represents only the presence of grain boundary resistance and no bulk, a less or no bulk resistance. Now to understand the mechanism of hydroelectric cell, so first tin oxide has low defect formation energy and unsaturated surface cations. So what happens? Firstly, the water dissociation of water molecule takes place on the tin surface. As the water gets adsorbed tin surface, it gets dissociated and forms an SNOH layer. And on this SNOH layer, due to hydrogen bonding, further multi-layer adsorption of water molecule takes place. And due to the presence of pores, the H3O plus ion that gets adsorbed in the pores generate a high electrostatic potential of around the range of 10 raised to the power 4 volts, which is very high enough to dissociate the water molecule into H plus and OH minus ions. As we can see here, the OH minus ion go to zinc anode and it takes up 2 OH minus ions and forms zinc OH2 and release 2 electrons. And these 2 electrons go to the silver cathode. And here the H3O plus ion takes up the 2 electrons and release H2 gas. So it is pretty evident from the reaction itself. The byproducts even formed here are environment friendly, and this is an eco-friendly alternate for source of energy. So in conclusion, hydroelectric cell is an eco-friendly, cost-effective and potential green energy source. So mesoporous tin oxide prepared at 2 different temperatures resulted in enhanced surface area. And the cell prepared at 150 degrees Celsius showed better properties as compared to low temperature. So mesoporous tin oxide prepared can be a good candidate for hydroelectric cell with enhanced. This is the literature survey we did. These are the references. Thank you.
बजा दो एनीवन इस बार कुछ हो जाए क्वेश्चन नहीं
Yes. We have used other pellets. We have used other pellets to light bulbs, and we have used them in application of lighting lamps and small table fans also.
अच्छा यूज किया है
Yes.
ग्रेट और जो आजकल ये टोयोटा की कार है ये हाइड्रोइलेक्ट्रिक वहाँ यूज हो सकती है
So potentially
आप
we are
मतलब
research.
पोटेंशियल यू मस्ट हैव थॉट अबाउट इट कि उसके जो हाइड्रोइलेक्ट्रिक सेल आई थिंक दैट आल्सो यूजेस हाइड्रोइलेक्ट्रिक सेल इफ आई एम करेक्ट तो मींस उसमें और इसमें कुछ कंपैरिजन या डिफरेंस कुछ देखने की कोशिश करी देखना
बेसिकली हम वाटर यूज कर रहे हैं, दैट इज हाइड्रोजन.
वो भी यही क्लेम करते हैं although I have not worked on it but whatever the ad or the details about it says the water vapor is coming out of the car. It's almost like the same work. चलिए anyways you can look into it. Fine. एक लाइन आपके टाइटल के अंदर है यूरिया वर्ड का. Means what exactly is the role of urea over here when we are all getting like tin oxide in the end and that too by annealing. Annealing किसमें क्या फर्नेस में muffle furnace में तो यूरिया का एग्जैक्टली रोल कहाँ पे आता है इसके अंदर लाइक टिन ऑक्साइड आ गया तो फिर तो वो तो किसी भी प्रोसेस से आ सकता है.
सर टिन ऑक्साइड हम 3 तरीके से बना सकते हैं. एक हम सॉफ्ट टेम्पलेट से बना सकते हैं, हार्ड टेम्पलेट से बना सकते हैं और टेम्पलेट फ्री से बना सकते हैं. हमारी लैब ने तीनों प्रोसेस से बनाया था. बट यूरिया का यहाँ पे ये यूज इसलिए बेटर है क्योंकि जब यूरिया हम यूज कर रहे हैं इनिशियली हमारा जो सोल्यूशन है वो एसिडिक है. तो यूरिया क्या करता है, स्लो रिलीज करता है बेस को, जो कि जो हमारा SNOH थ्रू द प्रोसेस फॉर्म हो रहा है, मतलब इन सिटू जो फॉर्मेशन हो रहा है हमारा हाइड्रोथर्मली, वो SNOH का फॉर्मेशन स्लो कर देता है, जिससे हमारा जो स्ट्रक्चर है उसे फॉर्म होने के लिए ज्यादा टाइम मिलता है. तो मेसोपोरोसिटी उसकी एनहांस हो जाती है. तो सरफेस एरिया इंक्रीज करने के लिए यूरिया का यूज करें.
पूरी तरीके से टिन ऑक्साइड तो एनीलिंग करने के लिए कोई भी कंपाउंड डालोगे वो टिन ऑक्साइड का अगर होगा तो एंड में यही बचना है.
Yes, sir.
But
But
that point is correct. Right. Thank you so much, Mansi. Thank you. And last, I think we have a person, Anisha. She will be presenting on inhibitory mechanism of quercetin. Right. Anisha, are you here? Please.
A very good evening to all of you. I, Anisha, going to present my work entitled Deciphering the Inhibitory Mechanism of Quercetin against HIEPP aggregation using Molecular Dynamics. And I'm doing my research under the supervision of Dr. Bhupesh Goel from Thapar Institute of Engineering and Technology. So coming to the introduction part, you all must have heard about protein misfolding. Protein misfolding is basically a process in which protein fails to fold in its native conformation state and it adopts a beta sheet structure. Protein misfolding is associated with a number of diseases like Alzheimer's disease, Parkinson's disease, Huntington's disease, and type 2 diabetes. And currently we are working for type 2 diabetes, which is one of protein misfolding disease. So diabetes is basically occurs when the pancreas doesn't make enough insulin or when the body cannot use the insulin properly. So based on it, it is divided into two types, type 1 and type 2 diabetes. Type 2 diabetes is basically occurs when the body cells cannot respond to the insulin or becomes insulin resistant. So there is a protein called amylin or HIEPP, that is human isolate amyloid polypeptide, which is the main cause behind this disease. So what we are doing, we are targeting HIEPP with quercetin to see how it is interacting, how it is controlling the aggregation. HIEPP is basically a 37 amino acid peptide, which have a disulfide bond and has an amidated C terminus end, and it is co-secreted with the insulin from the pancreatic beta cells. So after doing the literature study, we have chosen quercetin because quercetin has been investigated to control the blood sugar and blood vessel function in T2D using in vivo studies, and CD studies showed that there was a sudden increase in the helical content of HIEPP, and this proves the disaggregatory effect of quercetin. So in the present work, molecular mechanism of inhibition of HIEPP aggregation was investigated using computational techniques. The figure shown in the panel A is the structure of our protein, that is HIEPP, and the figure shown in the panel B is the ChemDraw structure of quercetin. Next, in order to do so, we first performed molecular docking studies, and we did molecular docking because in order to find the binding interactions and binding energy of quercetin with HIEPP, and it showed a great binding energy, that is minus 6.8 kilocalories per mole. And these are the residues, that is arginine 11 and asparagine 14 were involved in the hydrogen bond formation with quercetin, and phenyl 15 and ASN 31 was involved in hydrophobic interaction with quercetin. This is the best dog pose of HIEPP with quercetin. The figure shown above shows the hydrogen bond formation, where two residues were involved in the hydrogen bonding, and one residue, that is phenyl 15, which has been reported to play a major role in the aggregation, was involved in pi-pi stacking interaction with quercetin. Next, we performed molecular dynamic simulations in order to check the inhibitory mechanism. And for that, we have created a system under the physiological condition of our body. And we performed molecular dynamics for around 500 nanoseconds. And these are the results of our molecular dynamics. First, we performed the structural stability analysis. And from structure stability analysis, we concluded that HIAPP was quite stable in presence of quercetin, as we can see from the RMSD, RG, and RMSF analysis, that average values was significantly reduced, although our radius of gyration value was increased, but it is not that significant. Next, we took snapshots of MD trajectory at different time points of our simulation. And from these snapshots, we can clearly see that helical content was significantly increased in the presence of quercetin, which is consistent with our experimental studies. Next, we performed DSSP analysis, that is Dictionary of Secondary Structure. And the figure shown in the panel A is for HIAPP, and the panel B shows HIAPP in presence of quercetin. And this blue region shows the helical content, and the DSSP also shows that in presence of quercetin, helix content was increased. This is the data that we got, that helix was around 37% for HIAPP, and in presence of quercetin, it was significantly increased to 56%. And also the beta sheet structure was reduced from 1% to 0%. So this shows the decreased aggregation tendency of HIAPP. Further, we performed hydrogen bond analysis, and from hydrogen bond analysis, we got a very good number of H bonds between HIAPP and quercetin. And also the intramolecular H bonds was also found to increase, which shows the stability. And these are the residues which were involved in the hydrogen bond formation. Next, we performed the principal component analysis, and from the PCA analysis, we can clearly see that trace values were decreased in presence of quercetin, which shows that conformational motions of our protein was restricted in presence of quercetin. Next comes the free energy landscape analysis, and from this analysis, we can clearly see that high energy conformation states were more in HIAPP than in comparison to HIAPP in presence of quercetin. And this data shows the helix and beta sheet content, and we can clearly see that helix content was significantly increased and the beta sheet content was decreased, which shows the stability of our system. Next, we perform the MMPBSA analysis residue-wise, and this analysis shows that which residue of HIAPP is interacting with our quercetin. So residues arginine 11, leucine 12, glycine 33, asparagine 35, and tyrosine 37 showed significant contribution. And the binding free energy was also found to be really good, minus 43.558 kilocalories per mole. So coming to the conclusion, the molecular docking results showed high favorable binding interaction of quercetin with HIAPP, and binding free energy analysis suggests that quercetin binds favorably to HIAPP. FEL analysis highlighted enhancement in helical structure, and the result from the present study will aid in developing new inhibitors to block the amyloid aggregation. At the end, I would like to acknowledge organizing committee for providing the platform to present my research work, committee members for their precious time,
my supervisor, Dr. Bhupesh Goyal, for his fruitful discussion, Thapar Institute for providing necessary lab space, and special thanks to my seniors and lab mates for their valuable suggestions. Thank you for your kind attention.
Thank you, Anisha. Anyone?
Bromos. Bromos. Yes.
Which questions? Right. So thank you, Anisha. I'll also, like, we are already 10 minutes more. Thank you so much. So with this, we are concluding our session, which is session 3 of this conference. So we had in this session 3 faculty members who had presented. One was a researcher, 6 PhD students, and 2 undergraduate students. This should have been higher. Deshbandhu College hai to discount deke bache aur aane chahiye the. It's always preferred. And then we had 11 what you call participating institutes. That's a very good number. So you all had given good presentations, and almost each and every presentation was socially relevant. Environment, like some were on the what you call waste reutilization, environment friendly polymers that you are producing. Then there was one which was interesting on the green coffee thing that I liked very much. Then we had one from Shobhana also. So all these are very good presentations. My only one point that I would like to add is that when you are giving like some nano composite or some nano material or some thing that you have devised, always show some picture that this is the end result that we have done. Although it might be a small sample or it might be in the powder form or something, but it should be there. It always gives what you call a strength to your work. That in the end, because right now also the government is promoting all those things which have applications. Only pure research is not being promoted. And in the years to come, we should all be ready for this, because most of you are what you call research students. Government will promote only work that is having an application. So whenever you are writing any project or you're working what you call writing any research paper, try to emphasize what final result will it be giving to the society, right? So thank you all. Thank you so much. If you would like to add some points.
No, thank you all. And we had very diverse presentations, and proud of you all, and you doing good work. And we have written briefs of your presentations. So we'll be putting them